Hello friends, in this lecture we will cover the next electronic instrument, that is function generator. Now the learning outcomes. Now after studying the function generator, students will be able to understand what is function generator, then the detailed block diagram of function generator, and which are the different applications of function generator. Now what is function generator? Now the function generator is an instrument which generates the different types of waveforms, and the most required common waveforms are sine wave, then square wave, then the triangular wave, and these various outputs of the generator are available simultaneously. Now let's see the front panel of the function generator. Now the first part of the function generator is the digital display. Now this digital display is used to display the frequency as well as the voltage, because our function generator is mainly used to generate the waveforms like our triangular wave, then the square wave and the sinusoidal signal. And to generate these waveforms we will require the amplitude or the voltage and the frequency, and this digital display is common for both the quantities, for frequencies as well as the amplitude or the voltage. Now the second part is the frequency ranges. Now here the function generator is used, that is 3 megahertz. 3 megahertz multi-waveform signal generator or function generator. Now if you see, there are several frequency ranges are available on this function generator, that is from 0.3 hertz to 3 megahertz. Means in this range, that is 0.3 hertz, then 3 hertz, then 3 hertz to 30 hertz, then 30 hertz to 300 hertz, likewise up to 3 megahertz. Means this function generator is mainly used to generate the frequency up to 3 megahertz. Now the third panel or the third part of our front panel, that is the functions. Now which are the different functions or which are the different waveforms which you can generate by using this function generator? Now first symbol indicates the sinusoidal signal. Means by using this function generator you can generate the sinusoidal signal. Then the second symbol, that is the triangular wave. Similarly you can generate the triangular wave or you can generate the square wave. So these are the three functions which are available on the function generator. Then the next part is the attenuation. Now this attenuation is used to vary our voltage, because as we know we always used our function generator to generate the AC signal. Now to generate AC signal or to generate some waveform pattern, we need the amplitude or the voltage, and the second part is the frequency. So to vary amplitude we require this attenuation part. Now, which are the different features of the function generator? Now, first, it generates the different waveforms like sine wave, then square wave, and the triangular wave. Then the second feature, that is wide frequency range, means you can vary the frequency from zero point 0.2 hertz to 2 megahertz. Then the third feature, that is 4-digit digital display with the frequency indication of hertz, then kilohertz and megahertz, and also the amplitude display. As we know, the amplitude display and the frequency display is common for the function generator. And the last feature is the maximum waveform amplitude, that is 20 volt peak to peak. Means this function generator is used to generate the amplitude or to generate the waveform of the amplitude which is maximum, which is up to 20 volt peak to peak. So these are the various features. Now let's see the block diagram of the function generator. Now in the function generator, the frequency is controlled by varying the magnitude of the current which drives the integrator, and the frequency controlled voltage is used to regulate two current sources, namely called as an upper current source and lower current source. Now upper current source is also called as constant current source supply source 1, and the lower current source is also called as constant current supply source 2. Now the frequency Now the upper current source or the constant current source supply 1 supplies the constant current to an integrator. Then the output voltage of the integrator then increases linearly with the time. Now if the current charging the capacitor increases or decreases, then the slope of the output voltage increases or decreases respectively. In this way, it controls the frequency. Now the voltage comparator multivibrator circuit changes the state of the network when the output voltage of the integrator equals to the maximum predetermined upper level. Now because of this change in the state, the upper current source is removed and the lower current source is switched on. Now the lower current source or the constant current source supplied to supplies the opposite current to the integrator circuit, and the output of the integrator circuit decreases linearly with the time. Now when this output voltage equals the maximum predetermined upper level on negative side, then the voltage comparator multivibrator again changes the condition of the network by switching off the lower current source and switching on the upper current source. Then the output voltage of the integrator has the triangular wave, and the frequency of the triangular waveform is determined by the magnitudes of the current supplied by the upper current source and the lower current source, or the constant current source supply 1 and the constant current source supply 2. Now to get the square wave, the output of the integrator is passed through the comparator. Then the voltage comparator delivers the square wave output voltage of the same frequency as that of the input triangular waveform. Now the sine wave is delivered from the triangular wave. The triangular wave is synthesized into sine wave using the diode resistance shaping network or the diode resistance network. Now in this shaper circuit, the slope of the triangular wave is changed as its amplitude is changed, and this results in a sine wave with less than 1% of distortion. And the two outputs amplifier provides the two simultaneous and individually selected outputs of any of the waveform functions. Now this is all about the block diagram of the function generator. Now this is how to generate the triangular wave, then the square wave and sinusoidal signal by using the upper current source and the lower current source. Now which are the different applications of the function generator? First, DC power supply test means our function generator is mainly used for the DC power supply test. Then it is also used as a clock source. Then it is also used to check the amplifiers or filters or attenuator circuits, etc. Thank you.